Welcome to another episode of the Cannabis Review. We've got an absolutely phenomenal guest for everybody today. I think we're going to touch on a lot of topics that most people won't have even heard of yet, but hopefully we're going to try and educate the viewers and everybody watching around Europe of this show. So without further ado, I'd like to introduce Jeremy Plumb. Jeremy is the Director of Production Science at Prūf Cultivar and one of the most renowned figures in this space in the world. How are you keeping, Jeremy? You well?
I am well, and it's great to be with you, and thank you so much for having me here.
It's not at all. This is my pleasure to have you on the show. So I think there's so many different topics that I'd like to talk to you about. You're a man of a huge amount of wealth and knowledge. But the first one I think is pretty much simple and straightforward, that we can kind of talk to the audience and talk to them about cannabis genetics. Basically, let's just give them an overview of what cannabis genetics are and where it all starts.
Wonderful. Well, one of the remarkable things about cannabis that I think we forget in the industry that's unfurling is that this is a plant that has been on at least 6 continents for thousands of years, and as a result, has created a kind of genetic diversity that is absolutely unprecedented in modern horticulture. Actually, as a facilities operator, when we get to that part of the conversation, I would suggest that most of the people who are advanced horticultural practitioners, when they're looking at the distinctions between this crop and many other crops, this is arguably the most important feature, is simply that cannabis is so diverse that it's very, very challenging to find sort of a one-size-fits-all approach. This diversity has been nurtured by cultures, around the world, but then greatly accelerated in the last decades, especially in the last 50 years on the west coast of the US. Places like Big Sur, California really ended up channeling cultivars or cannabis genotypes from all over the world. And, sort of hippies on the West Coast were always looking for special new plants. Of course, there's been a lot of sort of political influence on the kind of cultivars and genetics that have been developed in the last decades. I think a lot of people aren't aware that when the drug war started to heat up, we really saw a massive shift in the kinds of cultivars that were being grown. And especially, we used to see a lot of longer maturing plants that had low yields and were defined by features like terpinolene as the lead terpene or aroma, and sort of moderate THC. And these were a lot of what the plants that were preferred in that time. But as a result of the drug war, we had to find, essentially plants that were very, very rapidly maturing, heavy yielding, profuse in the resin production. And these plants were largely sourced from Afghanistan and similar places. So what we saw was a massive shift towards Afghani-dominated genetics on the West Coast, which have now been incredibly outbred. Quickly, an idea in genetics that's important to understand is the distinction between inbreeding and outbreeding. We talk about cannabis landrace varieties, and these are really inbred varieties that were in an ecological island that maybe for thousands of years had no contact with other diverse cannabis cultivars. So males and females in a population were inbreeding and creating a kind of stability in that gene pool. It's really disruptive when you then add a plant from the outside in terms of the genetic equilibrium of that particular population, because now you introduce a whole range of new possibilities, either from the agronomic perspective, like how a crop grows and what sort of morphology or physical structure the plants express, as well as all of the phytochemical inventory. So outbreeding is really when you take these divergent populations and combine them. And this is what's happened on the West Coast. I think that if you took basil and say basil was very desirable to humans and had been grown all around the world for thousands of years and had been prohibited, you would see an explosion of unbelievably diverse varieties of basil. But of course, that has not happened. It has happened in cannabis. And I just think there's really no corollary. So there's a 2.1% swing in the genome. And to put that in perspective, that's like a human to chimpanzee in terms of the genetic spread. So it's unbelievably diverse. The kinds of features you can expect to see in diverse cultivars could lead to maturation timing that a plant is completely at senescence or peak maturity by 5 weeks of blooming, or as much as 18 weeks, or non-photoperiod determinate. But so in any case, trying to accommodate all of these diverse genetics becomes a real art. I would say that cannabis genetics are actually one of the most exciting sort of narratives that I've personally been investigating, but I would urge anybody who's tuning in to check out the work of Rob Clark and George Merlin. Most recently, in a book published in 2011, Cannabis Evolution and Ethnobotany, they do a fantastic job sort of attacking some of the old misunderstandings, both about taxonomy or how we curate cannabis genetics or come to understand the diversity of cannabis genetics, and the ethnobotanical perspectives associated with the use of the plant. But it's an amazing resource, and in the briefest possible summary, we're really challenging this notion that cannabis genotypes are typically broken up into indica, sativa, and ruderalis profiles. And these were taxonomy or sort of terms that were used to describe physical morphology of the plant. So literally narrow leaf or broad leaf plants are two of the morphological distinctions that we see. And so if you have a broad leaf, that was traditionally considered an indica, and the sativa was the narrow leaf. These varieties are so much more complicated than that oversimplified taxonomy that unfortunately just does not any longer serve us. So there's really an evolution to see cannabis genetics from a new light. And the way that Rob Clark attacks it, which I think is the most meaningful response I've heard to date, is we're really dealing with narrow leaf drug varieties, or NLD, narrow leaf hemp varieties, or NLH, broadleaf drug varieties, or broadleaf hemp varieties. There's also a fifth position, which is the putative ancestors, which are gone. And what's remarkable is if you use this filter, then you can look at it from more of a genomic science perspective and understand that from a genetics perspective, we're dealing with alleles or genes that essentially have different traits that will express in terms of the kinds of phytochemical inventory being produced. Specifically, there's a BT and a BD allele. Each one of these is associated with the synthesis or the production of THC or CBD. So you can find plants that have, say, in the narrowleaf drug or broadleaf drug varieties, both BT and BD alleles. And this means that you have a range of possibilities in those cultivars in terms of what kind of chemistry it's producing. And that range could go from a high THC type 1 plant to almost no CBD in the type 1 category. Type 2 is a category of plant that has a mixed ratio of THC and CBD at varying levels, but always lower than you would see in a type 1, or in a type 3, which is a high CBD plant. And a lot of what we're cultivating as hemp in the US now is in fact not a narrowleaf hemp variety or a broadleaf hemp variety, but it's actually a type 2 cannabis variety that is capable of having both the BT and BD allele. The true narrowleaf hemp varieties are distinguished by actually having only the BD allele and therefore lacking the ability to produce in the biosynthesis of the cannabinoids this THC compound. So really, from a chemovar perspective, which we'll get to, and this word chemical variety is really the most important term from a consumer-facing perspective. It's and we'll get into some of the complexity of that as we talk about phenotypes. But the different chemovars are really related to this new update in the cannabis taxonomy, and I would suggest that that's a far more useful frame to begin any conversation with when we're talking about genetics than a indica, sativa, ruderalis perspective. Yeah. There's a lot else to say about cannabis genetics, and I would share just in the recent time, because we could go back to prehistory and look at how cannabis and hops were actually the exact same plant until a virus attacked that plant, and a mutation resulted in these two plants, humulus and cannabis, really bifurcating in the gene pool. So for those who don't know, that's the nearest cousin of cannabis.
I didn't know that. I tell you that much for nothing. I'm writing it all down here as we speak.
Fantastic. And we love hops, and hops are so fascinating in that you see some of the kind of evolution of genetics as you contrast hops to cannabis, where in hops you have resin that's on the inside of the flower. The capitate stalk trichomes are really internal. On cannabis, they're facing externally. But there's a lot of parallels, even down to the biosynthesis of aroma compounds like terpenes or other compounds, aldehydes, esters, ketones, but not cannabinoids. this is what the distinction in the gene pool really is with relation to cannabis that's most significant, in my opinion, is simply the ability to produce cannabinoids. There are other plants that we see some kinds of response that it looks like a cannabinoid-like biosynthesis, but really cannabis is quite unique in its ability to prolifically create this really, really miraculous category of therapeutic compounds. But the evolution recently in cannabis genetics is a bit fraught because, well, on one hand, we have this massive outbreeding project where people from around the world have shared cultivars and they've funneled through largely California and Oregon, and then they've broadcast out. They've also funneled through the Netherlands and a few other regions in the world. But the reality is we've seen some extensive genetic bottlenecking. So if you're doing a mature genetic development program and want to say create a sort of really ideal cultivar for commercial production, you would probably spend a lot of time sort of working on the pathogen resistance and the agronomic characteristics like the hardiness to all of the conditions in the field and the maturation, obviously the biomass capability and the phytochemical capability. But one of the problems we see is that if you select cannabis genetics in populations of less than 200, you're ultimately going to be responsible for bottlenecking that population. So while we see tens of thousands of names, I think we're literally into those kind of numbers now that we have so much regulated cannabis activity of these diverse cannabis genetics, it gets very confusing from the consumer perspective. I mean, it's very challenging to differentiate all of these different names and just see this continuous profusion of novelty and understand how to relate with this product. I think that really it is an important time to start to reframe and revisit some of the prohibition era sort of cannabis pseudoscience and the cultural response that's happened, and to update that with plant science so that we can be more meaningful in serving the sort of future demographic, which includes all of the non-cannabis culture people that can, profoundly benefit from a meaningful relationship to cannabis. That really, it starts a lot with the cannabis genetics. So on the West Coast, we see a prevalence of strain names, and there's this assumption that strain names carry attributes. For example, if there's a plant called Blue Dream, which was a widely produced popular plant on the West Coast for a long time, people expect that it has particular features and the kinds of effect that it's creating. And unfortunately, this is misinformation. And this is probably a nice segue into this conversation around phenotypic expression of cannabis. So when you take a particular genotype, say this particular cutting of Blue Dream or a seed germinated genotype of a Blue Dream plant, then you put that into different environments, you now are unlocking these what we call G times E interactions or genetic times environment interactions. And what this means is the genes do not predetermine the outcome of the plant. Actually, the phenotype or the expression of this particular plant will be the combination of the genes of that plant and what happens in the environment around the plant. Some of the variables that affect phenotypic expression in cannabis that are most important are light intensity, light quality featuring spectra, irrigation frequency, the media, the kinds of fertilizer and intensity of micro and macro minerals being applied, the even integrative pest management strategies, the cultural practices, the harvest timing. There's just a ton of variables that get poured into how a particular genotype related to all of these environmental considerations then results in what we call a chemical phenotype or a chemical variety. So a chemical phenotype or chemotype is actually the most important aspect of the outcome of our production processes and particular genetic stock. But we're really sort of maligned in the kinds of emphasizing that we see on strain names, where people are talking about indica and sativa as if there is a neat divide in the cannabis genome that allows for one half of the output to get you really excited and euphoric, and another half to be relaxing and sedating. Obviously, with over 500 bioactive compounds, this plant is a lot more complicated than some simple binary. But back to the genotypes, if we can at least start to walk into a bit more of an accurate taxonomy and understanding of what the starting material is, that's the first really wonderful move towards a more mature conversation around cannabis genetics. But then we have to deal with phenotype and how really there's a tremendous amount of what we call phenotypic plasticity in cannabis. This is a great word. What we see is that this plant, much like many other therapeutic plants and things like hops and obviously viticulture, when you grow it in these different environments, and we can speak about terroir and a lot of other concepts that are trying to get at this, but you see radically different outcomes from a chemical inventory perspective and also from a crop morphology perspective. One little great narrative that I always loved, I grew up in California and have been a part of the cannabis movement really since my birth, honestly. I was kind of thrown into this, but I was aware of a lot of people who were very passionate about Kush in Northern California and really claimed to have the absolute best expression of this particular plant. I visited Colorado on a talk like 5 years ago, and I got to go up to this community called El Dorado Canyon that's outside of Boulder. And it's more than a mile high. It has an arid growing environment. It has a pretty high UVB index or UVI. And these factors really affect the morphology of the plant. I will share that the plants I saw there absolutely were some of the most beautiful versions of like these classic Kush profiles I've ever seen. It just gushed resin. The aroma was overwhelmingly intense. And when I look at an evolutionary biology perspective, you can see that these plants are actually on a longitudinal line, line up with Kabul, and really are sort of very, very close proximal conditions to where these plants evolved over a long period of time. And it makes sense to me that they performed better there than, say, in Northern California, where we have lower elevation, a longer growing season, a lot more precipitation and relative humidity, and a lot less UVI. I mean, those are some of the variables. Obviously, you have to deal with soil types and mineral composition and all kinds of things. But that's a demonstration of like, that's the same plant grown in two environments with radical outcomes. At Prūf, I have the privilege of having many different environments, which I can, in a controlled way, using precision ag or controlled environment agricultural techniques, essentially emulate these different sort of origins of cannabis, and in order to optimize the expression of this really diverse range of cannabis genotypes. I think one of the sad things that I've seen happen in the industry personally is that we see a lot of facilities that are constructed with just massive canopies that have maybe 160,000 square foot warehouse in Colorado with many, many different kinds of genotypes, all receiving the exact same 2-part mineral salt fertilizer, the same lighting treatment, very often even harvested on calendars with little regard to the individual genotypes sort of peak performance, which may not be peak potency, but peak quality. And in any case, we see this sort of one-size-fits-all model widely employed. And that's never going to be a model that I think will produce the most exciting versions of optimized cannabis. And so when I have a phenotypic expression of a plant that I've bred that has a very unique set of circumstances, and I would take Astralworks as an example. Astralworks is a type 2 plant that I've bred that actually excitingly recently won a gold medal at this year's Cultivation Classic, which is probably the most scientific means of evaluating cannabis product qualities that we've seen in the world to date for a large group of people. This includes over 100 producers in Oregon using real apples to apples results with a neuroscientist overseeing results. And full disclosure, I'm a co-founder of this event 5 years ago with Congressman Blumenauer, but this was an effort to try to understand both what's going on in the diversity of cannabis and to educate the producer community to be very sophisticated and finding the optimal phenotypic expression of these plants, and a little bit of competition around that. We've seen a huge evolution in producers' proficiency in the last years as a result. But back to Astralworks, this is a really remarkable plant that it just is unbelievably high biomass creating. It's yielding around a 1-to-1 or a 2-to-1 profile of CBD to THC. It's terpenoline dominant, so it's got this bright floral intensity, and it's got a lot of anthocyanin, which is what gives this pigment the deep blue and purple hues. So it's a phenomenal plant. But this plant needs particular conditions to express in that way. If, for example, I brought this plant into a lower light intensity or a less fertilizer intense program, then it would tremendously underperform. It would look literally like a different plant. So back to the consumer, the problem is then if you're trying to find, say, a pretty consistent experience and finding what set of chemical inventory is speaking to your needs And I would really argue that we do not have the kind of research that we will have in the future, where we can start to talk about this more personalized expression of cannabis in a fundamental way. But we know that right now, at the very least, we can curate the phytochemical inventory and educate consumers to have some relationship and rapport with that inventory, and to observe, the effects, to practice titration, to discover the minimum effective dose, to practice socially responsible consumption, and really find a lifelong sustainable relationship with this amazing plant, and be shocked by how many other drugs it can very easily replace with far fewer side effects and increased quality of life. But this will never occur if we have strain names or sort of ideas like indica and sativa standing in the way of what really matters from the consumer perspective, which is the chemovar. So chemovar is a little distinct from chemotype. Chemotype, we have come to correlate as literally the analytical testing result for a particular batch. We have a chemotype for that batch. And say for Asterworks, batch to batch, we'll see some variance in the overall compounds it's producing. But the chemovar is like really more, I think of it as archetypal. It's a kind of expression of this range of all these different combinatory relationships of phytocannabinoids and terpenoids and all of the other chemistry. And I would say that we do need to evolve to a perspective where we can serve a range of chemovars with truly consistent expression in order for the consumers and patients to begin to explore this more personalized approach to cannabis. So it's very important to understand the cannabis genotype, how that then relates in the phenotypic expression by modulating all of these dynamic elements in the environment, as we do at Proof, seeking an optimal expression as validated by sensory examination and analytical testing results, and then stabilize that expression. Because then we really do afford this unique first time in history opportunity to explore this new range of chemovars and really unlock what I believe is this next chapter in a kind of wellness revolution that really can serve a broad array of people far better than the existing product mix and inventory in the cannabis market. And really, for example, focus on populations that are more 50 and up than under, or focus on women who have been really underserved in the cannabis industry, with this prevalence of a particular chemovar being the most dominant, which is a very high THC, high beta myrcene, or a sedative terpene profile that has a lot of different names, but is very, very iterative, and is really something that serves a lot of people well and has some wonderful attributes. But there are all of these other sets of attributes. So as producers, if we can master this genotype in a particular phenotypic expression and then produce consistent chemotypes, I think we're in a pretty revolutionary position to watch this expression of plant medicine have far greater impact on the world than it ever has before. And we're just at the beginning of that journey.
That's amazing. I've got a wealth of information just off those last few minutes there, and it kind of leads into the next topic. As you were saying, it's about the individual strains or the individual genetics being cultivated for a specific audience. So the horticultural art of cannabis cultivation, I think Ireland could, when we legalize, be one of the countries that actually is able to create a number of different people within this territory. Could you just give your thoughts on this part of the industry?
Yes, well, I'm very excited for what's happening in Ireland. And as we've spoken about, I see some structural advantages to Ireland being able to work with this unfolding industry and then be in a real early mover position with a lot of the rest of the EU coming online. So in any case, I think that one of the challenges for any new sort of community of producers is to find ideal cannabis cultivars or genotypes. The reality is there's a ton of cannabis seed available now. On the sort of internet, you can find just an unbelievable range of diversity. One of the big problems that we see with cannabis genetics is that we simply don't have a lot of QA or QC. We don't have the ability to accurately describe what these plants are, and I'll be more specific. Specifically, if we are buying by strain names or by breeder output, and we're not testing individual genotypes, and this is very important because say we have access to the new cutting edge of compound genetics, a brilliant breeder on the West Coast that's making, cutting edge hybrids, or, I'll put myself into the ring, new hybrids that I've produced. We're typically looking at what we call an F1, or a first filial generation of that hybrid. The hybrid is produced by a male and female. We have an XX and XY chromosome, just like humans. And then we have the parents and progeny dynamics. And in the progeny, we expect to see particular distribution of these traits between the two parents. But what I'm trying to get at is that each one of those seeds is actually its own plant, and that there could be upwards of 100,000 variants in a single XXXY pairing if we had sufficient seed and what we call high throughput phenotyping capabilities. And so the problem is, it starts right there. We have to do essentially cultivar discovery efforts to be able to know what we've got, no matter where we source it from. And the cultivar discovery effort needs to happen in advance of commercial production and output. A cultivar discovery program, like I've run at Prūf, we typically would say in the past, we've had 1,000 seeds that germinate at the same time. We track everything with a lot of intensive observation and compile lots of data. We take all the phenotypic data, which is like measuring at a high level all of the environmental conditions, the cultural practices, et cetera. And then we do the chemotype analysis. And then we start to understand the range of what this particular plant in this particular environment can do. From there, we can make informed decisions about what sort of plants are going to be favorable, both from, and it always starts with agronomic considerations. How well can this plant perform in the facility? Are we able to work with this? Is it, for example, a compact morphology that is early maturing and pretty vigorous and able to defend itself against abiotic and biotic stressors? If so, that sounds like a winner there. But then next, we need to see, does it produce a rich array of phytocannabinoids or phytochemistry? And are there different profiles that we're leaning towards? And once you select these plants, then we can begin the effort of stabilizing them. Stabilizing plants really means taking, say, that exciting new stock we've discovered through our discovery efforts, and now we have to sort of inbreed or work on sort of refining the expression of those traits through successive generations of breeding, whether we're inducing feminized seeds through the application of silver thiosulfate, or we are taking additional males from that same line and crossing those plants. Over the course of many generations, by selecting the correct plants, we can arrive at a sort of stable expression of the traits that matter most, a relatively stable expression, and then produce seed that is reliable. So for example, if Ireland was trying to distinguish itself from a genetic perspective, to have a reliable and exciting seed stock, it would be a tremendous advantage in being able to work with other producing regions. Another technology that's being widely used in horticulture is called tissue culture. And tissue culture can be very, very complicated, and it can be pretty simple as well. But essentially, we're talking about sterile propagation, or taking sort of an apical meristem or a node or some cross-section of the plant and producing that in a sterile handling environment, laminar flow hoods, and cultivating that plantlet and auger, and with a little bit of media recipe and nutrition and hormones. And then those plants, which can also be virus and pathogen free, can then be exported directly from a mother plant instead of finding, say, stable seed lines. Okay. I would say there's some disadvantages to tissue culture that aren't being discussed, and there's some unbelievable strengths. Right now, we have a really dynamic market with lots of new genotypes coming online. I mean, it's just obviously a massive tidal wave of new development, and it's pretty exciting to get to see all of the lab data at my own facility, all the lab data at the events, all the lab data at the retail dispensaries. And this is stuff nobody's ever seen before. And then start to parse that into maybe chemovars from an archetypal perspective, or to really understand the range of products that are out there. I think so. First, in order to select the best plants, we need to have a really great education about what the entire range of cannabis expression looks like. And the truth is, this is where, no matter how high tech we go with the industry, we continue to need to rely on the people who have the greatest amount of experience in the range and expression of cannabis as it's been experienced over the last decades, because this is going to be incredibly useful in selecting, the best possible examples of the plant. So we have this, I think, an equilibrium between experience and the new hort tech that's allowing for us to rapidly find a correct seed accession or a plant program that then could be the basis of sharing genetics to many other partner regions. I'd argue that genetics are absolutely the foundation of the whole supply chain, and that we're at a very early stage, that we can do much better than we've currently done. On the other hand, the cannabis breeders in the West Coast and around the world are some of the most innovative, brilliant, careful, selecting, passionate humans you could ever hope to find, and never to diminish or undermine any of the unbelievable contributions that have been and continue to be made there. It's just that I think as we're looking at a scaled expression of this, we are going to have to put in more investment, more time, larger populations, in order to make sure that future generations have access to truly successful cannabis genotypes and products that are really, really meaningful. The truth is, we could easily, through genetic bottlenecks and loss of old landrace varieties or inbreeding with outbreeding, where, for example, Dutch seeds showing up in a sort of, in Malawi or somewhere that hasn't had contact with outside genetics, we just are watching a kind of rapid loss of a lot of the heritage and the collective inheritance on the planet of all of this incredible cannabis diversity. We also know that just like viticulture and hops production, you see market dynamics come in and really hem all of this extensive diversity pretty rapidly to find a group of products that are the most consumer successful and useful. And while we're at such an early stage with such a mind-blowing plant that goes so far beyond what grapes or hops can achieve in terms of human well-being over the long haul, I would hope that we're working to preserve genetic diversity, and that we're working to preserve cannabis landrace varieties and the oral tradition and the rich history there, because that's a very, very important aspect of how we will continue to have a palette that can evolve over time to produce really vibrant cannabis plants for the next generations.
Amazing, absolutely phenomenal. I can't understate how much I've learned in the last 30 minutes, and I can only imagine how much the viewers have learned as well. It's been an absolute pleasure to talk to you. If anybody wants to know anything about Prūf Cultivar, here is the website here. Go visit it, check it out. Jeremy, I'm sure you're on Twitter and Instagram and all the likes.
I'll admit, I'm terrible on social media. I am on LinkedIn and Facebook currently. I should probably be more engaged on Instagram. But I will say the Prūf Cultivar website shows a little bit about some of the technology and the work we're doing. It's been pretty exciting in one of the most competitive states in the US to literally be the #1 producer in Oregon over the last 3 months. I've been there for 4 years now, directing with my partner, Todd Saucy. And the reality is, I think we've made an absolutely special organic culture there. And it's really worth tuning into in terms of people who are looking to production models. I see a lot of default decision-making going on around, say, mineral salt fertilizers. And I can share with you that I truly believe crop quality and crop purity and sort of the overall biological IPM benefits that the organic culture that we're building produces an amazing feature. But in any case, there's lots of cool geekery there, including photobiology and a little bit more about cultivar discovery. But people are definitely welcome to reach out to me in any channel. And it's an absolute pleasure to get to be with you. I'd always love to get to follow up with you again and get to continue to, 100%. In any way, be a part of the exciting wave breaking there.
100%. I'll definitely be having you back on the show again. I don't think we've even scratched the surface for the amount of knowledge you could bestow upon the viewers. So I can't thank you enough, Jeff or Jeremy, for coming on. It's been an absolute pleasure chatting to you. Thank you, everybody, for watching again another episode. We'll be back next week with another amazing guest, although it's going to be a tough one to follow after this episode. Until next time, guys.